Hey, so welcome to this next video of the ViZDoom series. So in this series, we're creating a machine learning model using Python PyTorch that's going to learn to play Doom by itself from scratch without knowing anything about it other than, look, there's some buttons and hey, this is some stuff you can see. We're going to get it to learn by itself. We're going to do that by using an algorithm called policy gradients, otherwise called reinforce. So where were we? Second to last video, learning worked. And so we added in a function to save the model. And we were looking forward to seeing how the model would play Doom. In the last video, we found that after training the model overnight, the learning had collapsed. So no model to run. So we did some accumulation gradients and started an experiment on that. In this video, a new run of that. So before that last video, we started running a new training. And that was like in progress in the middle of the last video. It's now finished, and as you can see, here's the reward graph, and it learned. So I basically stopped it after 40,000 episodes before it could collapse again. And so you can see that the reward started off at like minus 100 and minus 150 on average, and then at 40,000 episodes, it's gone up to like plus 60, which seems reasonable. So in this episode, in this video, we're going to show how the model plays. So let's go. Well, first we have to write some code to do that. That's going to load in the model. And then we'll see how the model looks. So, welcome. All right, so let's try having a look at running this model. So we're taking the model that's been trained for 40,000 episodes that looks like this, and let's see if we can run it. So I've put the model. Where did I put it? Okay, so let's make a folder. ViZDoom models. And then I pulled it from the instance into my pull folder, and then let's just move that into models folder. So the model is in ViZDoom models. It's only 27K, it's really small. I guess I could just stick it in the GitHub. I don't know. I'll think about that. All right, so then we want to try running it somehow. So we need to load it, and then let's make a script that's just for this somehow. Yeah, so let's do like ViZDoom run model. All right, so basically going to take large chunks of training script, which is ViZDoom part 6, which is ViZDoom part 6. We're going to take large parts of this, but we're not going to do any training. So I guess we can just like copy and paste this, and then remove the stuff that we don't want. So we're not going to save the file. We're not going to do a log file. We're not going to do any training. Let's remove all the stuff we commented out. We have a couple of options as far as when we're running the model. One option is we're going to sample like this. And then another option is we do the argmax. I guess we can try both and see how that compares. But for now, we'll sample because that's what we have here. Okay, I probably shouldn't have actually removed one of these today. Well, let's just do time equal naught for now, but we might slow it down a little. See, and then obviously we want to make the game visible. Like, all right, so and then let's add argparse to this. So at the moment, it's not using argparse. So like we'll use argparse in order to tell it where to load the model from. So let's use argparse, and I kind of want to just stick this into like a run function, and it's going to take args. And then down here we'll do like parser equal argparse.argument parser, and then args equal parser.parse args, and then run args, and then we'll give it one argument, which is going to be like the path of the model. So in like model path, something like that, type str true. All right, so let's try running that. All right, so we'll do Python ViZDoom run model in model path, and then that is in ViZDoom models, and I think there's only one. So let's run that and see what happens. Right, Python path, right. We should fix something. Um, well, that doesn't seem to be doing anything particularly exciting. It seems pretty random. So, oh, because I forgot to load the model. Right. Yeah. Right. So, instead of doing model equal this, we're going to do model equal torch.load args.in model. Right, let's try that. All right, there we go. Well, it seems to be working pretty well. I mean, that's pretty effective, I think. I think it's pretty convincing. Cool. Well, I think that's working great. It's not doing anything weird. I, I'm not. I don't think we even need to bother doing the argmax, to be honest. I mean, it's clearly just doing exactly what it should be doing. All right, so the model clearly learned it does exactly what we wanted it to do. Like it moves towards the alien and then it fires, and then it moves towards next to the alien and it fires. It's just bam, 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 bam. So that's great. I was kind of worried that the reward was high, but like maybe it was misleading us, but it's doing exactly what we want. So that's great. In the next video, we will take a look at how the gradient accumulation is going. And then I would like your ideas, suggestions, opinions on where we want to go next. Like, do we want to try a different environment, or do we want to stick to ViZDoom but try a harder scenario? Like, there are harder scenarios. Like the scenario where you just move left to right and shoot one alien, that's not the hardest scenario. There are some others where there are more than one alien and where the aliens keep respawning. So one option could be to start going for harder scenarios, see how the policy gradients works. If it works, then great, find something harder. If it doesn't work, then use something else, maybe like modify the policy gradients, maybe try some, is it DPO or something like that? There's some fancier policy gradients algorithms, or there's Q learning, etc. Let me know in the comments. And also, if you like the video, then please press like, and see you in the next video, hopefully. See you.